Hello, folks. Welcome to Rational Science. It's been a while. I had to postpone a couple times, but here we are. Anyways, because I postponed a couple times, I collected a lot of questions, and I'm not sure I'll be able to answer all of them. So if I don't answer your question today, all you can do is put it in again. Write it in again. Okay. Anyways, let's start with extinction. Are we close to extinction? Extinction of the human race. And the reason I mention it here, a fellow says, talking about the Ukraine war, right? He says, could well be the most dangerous period in human history. Yeah, in a way it is because we do have the power to destroy the world now. Talk about Pinky in the brain. Yeah, we have the power now. And I'm not talking about nukes. I'm talking about really destroying the global economy. If you destroy the global economy, uh, what that means is suddenly, money is no more. And if money is no more, that means that, you can't produce food, distribute food, or buy food. And so millions of people, billions of people die of starvation primarily. There could be some nukes being thrown back and forth, that should help the process. But the majority of people, I think, will die of starvation because suddenly the global economy will be dead. Okay? Without an economy, you don't produce food or distribute it to the cities where most people live today. Anyways, more dangerous, I guess, here is that right now, or the way this is headed, maybe, one possibility is that not only is this an attack against Germany and against Russia, primarily Germany, the United States conquered Germany without firing a shot, like I say, Germany and France primarily, Europe, continental Europe. Uh, it's against Russia. Obviously, they try to destroy the Russian economy, but this is also a war against China. Okay, it's a war against China because now the United States has raised the possibility that if China helps Russia economically during this period that the United States is trying to tighten the screws, well, then China's going to suffer. And the United States really wants to stop China from expanding. And this gives them a good opportunity to do so. They just threatened China and they said, look, if you help Russia, they might do what they did to Russia, confiscate billions of dollars that Chinese have, outside of China. One, and then the other one, they can stop commerce with Europe and the United States and all its colonies. And so that would limit China quite a bit. Chinese have to think a lot about that. And so you got to think about what's going on. The United States might kill two birds with one stone. At least I think it's trying for that. And I think this was planned way back when, some months ago. The United States goaded Putin to attack Ukraine. The United States doesn't care about Ukraine. I mean, they're all Russians anyway. So right now they have Russians killing Russians over there. The people suffering, all that stuff, that's good for propaganda. That's all that's good for. The important thing is, what comes out of this, and what is coming out of that is the United States has conquered Europe without firing a shot, is causing a lot of trouble to Russia, which has all these nukes. And one possibility is that if they overthrow Putin, maybe you get a friendly government in Moscow for a change, and suddenly it's Russia and the United States against China. And I think the Chinese are evaluating that possibility as well. So this is going to get interesting, no matter how it comes out, how it evolves. I think you have to consider all the possibilities. Okay, and there's a lot of speculation on the governments as well. What could happen on the other side, and it all depends on what people on those sides do. Like if the Russian military or some powerful people there overthrow Putin, the United States cannot predict that. But if it happens, hey, we've accomplished our goal. Okay, so yeah, it's going to get interesting in the next few days. Anyways, talking around that problem, Someone says it's not against Germany, meaning the war is not against Germany. It's against the last immense European white country. Whoa, a little bit of racism there, huh? And his sovereign leader, the first enemy of the capitalist empire. Whoa. Russia is hated because is the last immense white people European country undefeated by U.S. and unwilling to be ruled by financial elites. And all I can tell you is from a political point of view, I've never uh, been racist. I never cared about race at all. I always talked about humans doing this and humans doing that, but I'm colorblind as far as people are concerned. I'm not into racism at all. But no, I think Russia itself has a capitalist system, and it also is ruled by elites, by an autocracy. It's just the way it is. All countries have the same system. There is no different system on planet Earth. Okay, you have a few oligopolies, a few at the top and the rest on the bottom. It's no country is different as far as I'm concerned. So I don't think this is about racism. This is about imposing, one mafia on another. And is any of the mafias better than the other? Is Al Capone better than Bugs Moran or vice versa? The South Side versus the North Side? You shouldn't take sides. You should just try to be objective and see what happens. That's it. And see how it affects you. That's it. Okay, my recommendation. Anyways, someone says, even if there was a global power outage, some computers will still maintain the blockchain using solar, hydro, geothermal, or backup power. Yeah, I don't think so. If you have power outage, this is not a question of running a little motor at home and running your computer somehow. And here, let's continue and we'll answer that question or that issue. Paul says, the internet does not depend on satellites, but they are used for some internet providers like Starlink. Well, you got to think of we talked about the banking system. That's what we're talking about. We're not talking about, internet to see what's going on in Hollywood, okay? We're talking about money here. We're talking about the global economy, and if the global economy collapses, we're all in trouble. That's the issue, okay? That's the context. And so you look it up, it says the majority of our internet works through submarine cables. Now, because we were talking about, killer satellites, the fact that Putin at the last moment might decide to kill the satellites, and this fellow essentially is saying that, satellites don't run the internet, but we're talking about the banking system, and that's up there, okay? You need the satellites for the banking system. And anyways, a lot of it runs through cables under the sea. And you think the Russians have a harder time or an easier time of killing satellites or cutting the wires underneath the ocean with a submarine, for example? Are you going to patrol the whole line with your submarines? So I don't know. If things get really bad, they could kill the internet. And I'm talking about international banking. That's what I'm talking about. Okay, none of the other nonsense. Okay, so yeah, I can say that if the internet falls apart, we're dead. And I'm saying that if they cut the cables underneath the ocean or kill the satellites above, they're cutting the banking system. They're killing it. And here you see a little article. Okay, there's many of these on the internet, by the way. Why mobile banking would be unthinkable without satellites, the role played by satellites in our modern financial system. And it says the modern financial system is dependent on them. Okay, so keep in mind we can't live without the satellites, but if they kill the cables that go underneath the ocean, it's the same thing. And I think it's easier to kill that than to kill a satellite, I would think. Okay. Anyway, it says this article just went in there and went in some detail. You can read the article later on, but it says several billion transactions per hour. Precise timing is crucial. You transfer money, recipient returns it at a later time. If he returns it immediately, money arrives before it is sent. And money can't be at two places at once. These are some of the problems that it would create if the satellites were killed. Okay, right now we depend a lot on the internet for everything. Okay, and our very lives on this abstraction. On the matrix, we're part of the matrix. We depend a lot on that, and so we can't let it fall apart. If it does fall apart, we're all dead. Okay, so that's how fragile our lives are. It depends on maybe a guy like Putin who decides to say, "Hey, I've got nothing more to lose," and he goes in there and cuts the cables, kills the satellites. And he says, "Oh, you stole money from us. You kept all this money that we had abroad. Well, I'm going to kill your satellites and see who has the money." What is money after all? Faith. That's all it is. In God we trust. When we become atheists in money, we're all dead. Okay, here's now a fellow says people having 4 or 5 children per family will replace those with lower fertility. Europe may become more Islamic and the U.S. may become more Hispanic, but it's not that difficult to produce more humans. Poor fellow, he's not even close. He had no clue whatsoever. No, what he doesn't understand is what was it, 1963 was the last highest year that we had for growth rate. Since then, the growth rate has steadily, and it's important, steadily been declining. And there's no way we can turn that back. Once a species, any species, overturns its population pyramid, it can never recover again. And humans are no exception to that. No matter how intelligent we are, no matter how much technology we have, we cannot overturn the population pyramid ever again. From now, it's going to be declining, declining, declining until it reaches zero population growth, known as ZPG, which is predicted to occur sometime in mid-century, this century for sure. And that's if everything goes according to plan. People are not going to have children. And they're not having children, they're not going to have children. And the reason, we know the reason too, okay? And here's the reason, okay? People are moving from the country to the city. They're moving from rural areas to urban areas. It's known as a transition, the urban transition. Red line there, that's for the world. But you can see all countries pretty much are becoming more urbanized. So people are moving from the country to the city. They're abandoning the country, the farms, and those are being taken over by big corporations which have these economies of scale for producing food. And so, it's pushing people out of the country. And what's the issue? The issue is when people move to the cities, it's forbidden to have children in any country of the world. You can't have children in the cities. It's forbidden. It's outside the rule. There's a law against that. It's a natural law. Okay, it's known as density-dependent birth rates. Okay, and so no, we will not have children in the cities. Okay, maybe 1, 2 here and there, and ever less and less and less, fewer and fewer and fewer. So no, we're not going to have children. And so he says it's easy to produce children. We're not talking about sleeping and having a baby. Okay, we're talking about whether a woman wants to have a baby. Not only a woman, a man as well, right? But whether they want to have any babies. And in the cities, that culture is gone away. Aside from the economics of it, you can't maintain a child in the city, let alone 10. And nobody has 10 children anymore. 4, 3, 2, 1. Pretty soon it's going to be 0. Most couples just have recreational sex. That's it. No reproductive sex. That's going away. It's fading into oblivion. And there's no way governments can put a gun to your head and say, have children. Never going to happen again. Okay, so forget about having children. And what is children? Children is demand. No demand, that has to have an effect on sales of every company on the planet. More and more companies will be fighting for the crumbs, for what's left out there. People who don't have, I don't know, refrigerators or kitchens or whatever. And what's going to happen is a lot of these companies are going to merge, or one's going to declare bankruptcy or whatever. There's going to be fewer and fewer companies producing goods for whatever sales there is out there. And that's going to it's going to be a slow process where demand does not increase. Doesn't increase because population is not increasing. And what is population? It's demand. Demand is population. Okay, another fellow says, changing the subject a little bit here. Earliest evidence of modern humans in Europe discovered in France. NBC News. Okay, seems to suggest a layer of human habitation between layers of Neanderthal habitation. Did they hang out, or did they fight? Still no sign that we ever met. And you go to the article, this article came out recently, and it says the modern human group was part of an incursion from the Eastern Mediterranean coast. And they all come from the East Mediterranean, right? That didn't last long before they again vanished from Europe. So you go to this article, and the article says that they found humans, not Neanderthals, but humans in the middle of France, southern France, actually. And the group that they found, okay, suppose they found one tooth. And they said it's human. And because of that, they said there were humans in France 54,000 years ago. I think 54 or 56, but I'll check that in a second here. Anyways, they said 54, 56,000 years ago, there were humans in France, but that dynasty or whatever, that group, didn't last at all. That did not reproduce the population of anyone on Earth today. That's the argument, okay? Well, it's so convenient, you know. It looks like these people just wanted to publish their paper. That's it. And I'll tell you why. Here's my take on this, okay? Here you see, these are the caves that claim to have the oldest humans, supposedly verified humans, okay? The Pestera Cuoes in Romania, that's probably the best one. They found a jaw there, and it was dated to around 40,000 years ago, anywhere from 37 to 42,000 years ago. By that time, there were no Neanderthals in Romania, okay? So, yeah, I can accept that. The next candidate is the one in Bulgaria, okay, a cave in Bulgaria. And that one was dated to 43,000 years ago, and that's a little more doubtful, okay? Again, they try to push it back. Why? Because they want to show that humans and Neanderthals had sex, and that's how the Neanderthals disappeared. That's the theory. And so anything that proves the theory, that convinces people that the theory is correct, is accepted for publication. And so these people pushed it back to 43,000 years, and the new paper says, no, it's 54,000 years. We found it in France, okay? When you go to the article, it says, not to the article, but this is something that I think from Wikipedia referring to that article. It says, articles in the journal Science as well as in Nature said that the tooth, they found one tooth, okay, a child's tooth, was too badly damaged to be able to tell with certainty if it was from a Neanderthal or a human. Okay, and my take on that is, without knowing anything, without ever seeing, I'm saying it's Neanderthal. It's got nothing to do with humans. Humans were not in Europe, especially in France, 54,000 years ago. The best we can think of is maybe around 40,000 years ago, being in the East Mediterranean region. That we can accept, but 54,000 years ago in France, I doubt that very much. And here's the map, just so you can see where these caves are. Okay, there you have the Grotte Mandrin, which is the one that recently published that 54,000 years ago in France they found this tooth, which they don't know if it's human, but these people claim it's human, so that they can claim that they found the first human ever to step foot in Europe, you know. There you have the other two, the one in Romania and the one in Bulgaria. Okay, and it suggests still that there was a migration of humans, Cro-Magnons, right? People who humans who entered Europe, and they probably came from Africa. Okay, the out of Africa theory. Okay, and maybe they went around the Black Sea there. Maybe they went through Turkey, through Istanbul. Who knows? But somehow they found these remains, and this I can accept a little bit because I think by then the Neanderthals were no longer living in that region of the world. In fact, I think the Neanderthals made their last stand in Gibraltar over there in southern Spain. That's probably where the last Neanderthals lived, and they vanished away. By the time humans arrived, all they found were dead bones, maybe from long ago. They probably arrived 1,000 years after the Neanderthals disappeared. So I don't think they ever met. At least this theory of sex, you know, that the Neanderthal disappeared because they were a much smaller population and they were kind of absorbed by the hordes of humans that came into Europe. No, I don't buy it at all. It's absolute nonsense. And here's why. We'll see here in a second. Fellow asks me, he says, do you have any opinion on Danny Vendramini's theory? Okay, and Danny Vendramini has not so much a theory. The theory is the same one as the establishment. But Vendramini and I, what we look eye to eye on is the following, and is what did the Neanderthals look like? Okay, and here's the one from 1909, probably one of the first notions that we had, the image we have of Neanderthal. And from there, people that said, oh, they were brutes, they were backward, they looked like monkeys, they looked like gorillas. And Vendramini pretty much says that he agrees with that. That's his version of Neanderthal. And the official line is the guy on the right. And by the way, that one from BBC 2013, that's an image that they made of the same Neanderthal that you see in square number one, the 1909 Boule-Kupka Neanderthal. So we have these artists, and they came up with totally different versions of what Neanderthal looked like. Now, if you were a girl, I mean, I can't say for men, but if you were a girl and, they put a gun to your head and they say, look, you got to sleep with one of these three guys, I think you would choose the guy on the right. That's what I think. Of course, I don't know, maybe some women are masochists and they want to be punched around. I don't know. But I would think most women would like to sleep with the guy on the right if they had no choice, okay? Yeah, Neanderthal has suffered the greatest evolution in the last 100 years. Went from being a monkey to being a Hollywood star. And why? Because they're trying to push a theory. They're trying to push the interbreeding theory, the admixture theory. They want you to believe it because they have no other explanation for how the Neanderthals disappeared. And so they brought in the geneticists and they say, do a genetic analysis on these guys. Well, they found no mitochondrial DNA, which comes from the mother. Okay, so humans have no mothers, no Neanderthal mothers. And then they checked also the, the Y chromosome of males. And none of us have any Y chromosomes from any Neanderthal. So we had no Neanderthal fathers. So let's see, we have no Neanderthal mothers, we had no Neanderthal fathers. Sounds like we have nothing to do with the Neanderthals. And they found 2% to 3%, they try to stretch that out, some people even claim it's 6%, commonality in nuclear DNA with the Neanderthals, which could readily be explained that we had a common ancestor 800,000 years ago. And so with that tiny bit, they say, we know what happened. 50,000 years ago, we met up with the Neanderthals. We had a great party, swapped wives, and we came out of those groups. Okay? And Vendramini essentially says the same thing. Okay? He says that somehow, the Neanderthals went to the Levant, especially areas around Israel and Iraq. And over there, they met up with us humans coming from Africa. We drank beer, we swapped wives, okay? And he says, look, this is the theory. The theory is the Neanderthals, they killed a lot of our people and they raped the women. Again, you saw that gorilla, he was interested in our women. Okay, so they raped our women. The women were pregnant with hybrids. Those hybrids grew up, and those hybrids later on killed humans and Neanderthals, and we are the descendants of those hybrids. That's his theory. And so what do I have to say about that? Well, here's in a nutshell what I have to say. Okay, I'm saying that Neanderthals were never in the Levant. Never. They found some skeletons in a couple caves in Israel and Iraq, and also Syria, that whole region there. Okay, they find some bones here and there. People who studied those bones in great detail, and there's differences of opinion here, but they claim that those Neanderthals, those bones, they don't match the Neanderthals of Western Europe, Spain, France, Germany, Belgium. The bones are significant or noticeably different, the ones that they find in the Levant compared to those in Western Europe. So you got to look that up. Whenever they say that there were Neanderthals in the Levant, in places like Iraq and Israel, you better look very closely for other papers, because you will find that people disagree that, they don't agree that those were Neanderthals. Okay? And my argument, again, is against that, saying that Neanderthals never had any reason to venture south. The Neanderthal was an animal made for the Arctic. He would have. Can you take a polar bear and put him in the equator? That's essentially what you're saying that Neanderthals did. That they migrated all the way south to the Levant, and I'm saying that never happened. Neanderthals lived and died in Europe, Western Europe primarily. How far east they extended, I have no idea, but I'm saying that if anything, it's Europe. That's it. Never in the Middle East you find a Neanderthal. So Vendramini's theory that somehow these Neanderthals raped our women, and then the offspring of those killed both Neanderthals and humans, and they were the survivors, and we come from that stock. That's only based on, again, he wants to be at peace with the establishment. And I'm saying none of that has anything to do with how the Neanderthals disappeared. The Neanderthals disappeared when their population pyramid overturned and they lost their genetic diversity. Two whammies that they got. And that's the same for any species that dies in a background extinction. So the mechanism for background extinction is the same for any species as far as I'm concerned. Okay, so that's where I stand. Okay, moving on to a couple other issues. We had the loonies and the moonies, and we have a couple people who are still trying to struggle with the spin issue. Okay, I'm just going to mention them. One fellow says, have you ever watched the moon for an entire night? Take photos every hour? The moon sure rotates. It does not spin. Rotate, but does not spin. You look up the word rotate, it says, to cause to turn around an axis or center point, to revolve. And what is spin? You look it up, it says revolve or to rotate. And then another fellow over there shows why we can't use these synonyms, because they all get confused and they talk past each other. The fellow says the moon does not spin on its axis, but it sure does rotate, meaning orbit, around the earth. You see where the problem is. These people go back and forth because they use the wrong words. They're using the word rotate without defining it. And one guy means orbit, the other guy means spin. That's the problem. Okay? And so, this is what I said the other day. I'll say it one more time for last time, I hope. And that spin to turn around an axis, and to orbit to move in a curved path around another object. Okay? So does the moon orbit the earth? Yes. Does the moon spin? No. Okay, why doesn't it spin? Because it does not turn around its axis. And then the idiot comes in there and says, oh, but it does because, see, it takes 27 days to turn around its axis. Very slow top. No, it doesn't turn around its axis because the axis is rotating with the moon. Okay, you can't use a one-dimensional axis, which is what the mathematicians use. You cannot imagine a one-dimensional axis spinning, let alone imagine a one-dimensional axis to begin with. So the issue never popped up in the minds of the mathematicians whether the axis, the one-dimensional axis, is spinning together with the moon. So the fact that the moon goes, in other words, orbits around the Earth, does not mean it spins on its axis like a top spins on its axis. And they say, well, it takes 27 days to spin on its axis. Absolutely not, because the axis is spinning together with the moon. If we were to, select a mountain or a valley on the surface of the moon, and we could put a stick, a three-dimensional imaginable stick, not an unimaginable one-dimensional stick, but a three-dimensional stick right through the moon, and we hold it still, the moon would not be, that mountain would not be changing its location with respect to the axis. A three-dimensional axis. To the atoms that comprise the three-dimensional axis. That's physics. Now, mathematics, they don't care about that. So they put a one-dimensional axis and they say, yeah, the moon spins because it rotates. What do you mean by rotate? That spins on its axis. So they're chasing their tails around because they don't define these terms. That's what it's all about. Okay, another fellow says, went to the other side. Give me a second here. Says, here it is. So the moon does not spin because its axis is tidally locked to the object which the moon's axis is orbiting. Have I understood that correctly? Poor fellow. What does tidally locked have anything to do with spinning? Does the top spin because it's tidally locked with the walls of your house? Is that how you determine whether the top is spinning? My God. No, we define the word spin, and then if it matches the definition, we call it that. We say that the top is spinning. And if the moon matches the definition of the word spin, we say the moon is spinning. The problem is it doesn't. Why? Because spin requires that the axis stands still and the mountain on the outside, on the surface, change its location with respect to every atom of that axis. Three-dimensional axis, not one-dimensional mathematical axis. No such thing in physics. Okay, and here we have another fellow, and he's a flat earther, and he says, funny how some people still believe in nukes and satellites. Do you think you ever saw a real satellite image? My poor God. Yeah, you have people who are still living in the Stone Age. And my only question is, what are these people doing in science? They should be in church praying or, cleaning latrines or something. They don't have the brains to do science. Why do these people come into to science sites? What are they looking for? And this is what Googles my mind, flat earthers, what are they doing in physics? Okay, moving on now. Let's move to the subject matter today, which is space-time. What in the world is space-time? And I'm going to start with ether, because the ether has something to do with space-time, okay? General relativity, special relativity. It kind of led to relativity and also quantum mechanics for that matter. And it's because in the 19th century, pretty much everyone believed in the ether, that there was this medium out there, what I call bunch of particles, okay? A lot of people get offended. They say, oh, it's not a bunch of particles. And yeah, it's a bunch of particles. That's what the ether is. And what the scholars of the 19th century believed was that light was a vibration of the ether. Meaning what? Of the particles of the ether, which is the correct way of saying it. When people say it's the vibration of the ether, that's where they make the big boo-boo, grammatical and semantic error, and they don't realize that. They say, oh, it's the vibration of the ether. You can't say that. That's like saying that it's the vibration of the forest. Well, you can say the vibration of a tree. You can say that the tree is shaking, but you can't say the forest is shaking. Okay? And that's the difference between a particle or a few particles within the ether that make up the ether, and to say that the ether is vibrating and that a electromagnetic wave or a transverse wave is the vibration of the ether. No, the forest does not vibrate. There's no waving of the forest, because if the forest waves, then it waves with respect to something outside the forest. Forest is not a physical object. Now, it could under one context. You go to a kindergarten and the baby, the 2, 3, 4-year-old toddler, he goes in there and he draws something. And what does he draw? Well, he draws, a green region on his paper. And someone asks him, what is that? And he says, that's the forest. Okay. But then you can't go in there and say, well, the tree is the air is blowing one of the leaves of a tree. You can say, you can't talk about the tree because the forest is all the trees, and now we're going to talk about the forest. You either talk about tree or you talk about forest. You can't say that because a forest is made out of trees and the wind blew the tree and shook the tree, that the forest is shaking. And that's the error these people commit with the ether. They think that because light is the vibration of the ether, when they really mean vibration of the particles that comprise the ether. If you're going to talk about that, talk about the particles. Don't talk about the ether. Okay? Ether is the whole shebang. You can't say the whole shebang vibrates. Okay? I hope someone got the message. Okay, anyways, we start with issue a person raised, and he says, Bill can't explain where the ropes comes from. The origin of the ropes are from the medium itself that they called ether. An etherist guy here. Which is not a bunch of particles, as he states. It's conceptually an incompressible fluid. Okay, let's look up what a fluid is. Fluid is a liquid, gas, or other material, blah, 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 blah. So what's a liquid, gas, or material? Well, you look them up, it's a bunch of particles. So all he said is that, yeah, the ether is a bunch of particles. But Bill said it's a bunch of particles. I don't agree with him. I think it's a bunch of particles. He said it's the fluid. What is a fluid? There is no physical object called fluid. Okay? Like there's no physical object called solids or gases. Okay? These are categories, what they call states of matter. So you can't say that ether is a fluid because you haven't said anything. And again, you either talk about the ocean or you talk about the drops of water that comprise the ocean, or the molecules that comprise the ocean, or the atoms that comprise the ocean. Okay? You can't say the ocean waves because, a little bit of water waved. You either talk about the little bit of water, or you talk about the ocean. You can't talk about both. You can't generalize and say the ocean waved. If the ocean waved, then the ocean waved with respect to something else. Okay, let's get the semantics right. People never learn to talk, and so these people are confusing, the particles that comprise the ether with the ether. Okay, and regarding what he said, that ropes, he says, I can't explain where the ropes come from. I've already mentioned that quite a bit. So let's go through it one more time. Single thread is all there is in the entire universe under the rope model. This thread turns into ropes, atoms, ropes, atoms, ropes, atoms. We're done. It's been there forever. Why? Because something cannot convert into nothing, and nothing cannot convert into something. We're done. So there is no origin to matter, as in religion, as in mathematical physics, where they say that matter came into being. And people say, well, that's not really what Big Bang says. Big Bang just stops just short of that, just shy of that first frame of the film. Well, they're wrong also there, because it turns out that in quantum mechanics, they say particles come in from the void. They're created from nothing, and then they go back to being nothing. So in mathematical physics, they do have creation of matter. They say nothing turns into two particles, and two particles turns into nothing, called a virtual particle. That cannot be experimentally verified. It's just mathematically put ad hoc. Am I getting through to anyone there? Okay, so that's the issue. The issue is, yes, mathematical physics, like traditional religions, believes in the creation of matter. They think that space, nothing, can turn into something spontaneously. Length, width, and height suddenly pop in. The rabbit pops in from nothing. That's what they believe in. And what we're saying is, no, matter is eternal. Why? Because matter cannot turn into space, nothing, and nothing, space, vacuum, cannot turn into something, 3 dimension, length, width, and height. Period. We're done. And because space is not a thing, it does not have a surface, it does not have form, therefore no object, not even God, can leave space, because there is no boundary, no surface to cross, because space is nothing, meaning it has no shape. I hope someone got that. Okay, but where do we get this ether thingy? Okay, well, let's go back in time, because people still insist, no, the ether is something that's not a bunch of particles. So let's prove to these people. They like proof, they like evidence. Okay, let's prove to them that the ether is bunch of particles. That's the definition of ether. Again, ether is not a physical object, it's a concept, abstract concept, means bunch of particles. Bunch of particles does not an object make, okay? Bunch of particles is not an object. Object is that which you can point to. You point to an elephant, not to a bunch of particles. You point to the table, not to a bunch of particles that comprise the table. Table is the whole thing, not each individual particle, the billions of particles that comprise the table. Okay, we got that? My God. Okay, so here we have it. We have Robert Boyle. He's one of the first guys who did it, who came up with this notion of ether. Actually, it was several people. Torricelli before him already talked about, particles of the vacuum, or whether the vacuum was comprised of particles. Another one was von Guericke, who did the first vacuum pump. Anyways, ether consists of subtle particles. That's what Robert Boyle said in around the 1660s. In the 1660s, he said this, or maybe even a little earlier, maybe late 1650s. Anyways, Isaac Newton, I do not know what this ether is, but if it consists of particles, right, particles, then they must be exceedingly smaller than those of air. The exceeding smallness of its particles, talking about the ether, of its particles, right? I hope people are listening. I said the word particle, okay? May contribute to the greatness of the force by which those particles, right, may recede from one another. Thomas Young, a couple of centuries later, says the ether consists of mutually repelling subtle particles which are attracted to particles of matter. What is the ether? It's a bunch of particles. Anyone who says anything different is an ignoramus. He hasn't done any research on the word ether. They start using the ether. They say, oh, the ether does this, the ether does that, and they don't even know what the ether is. So when I tell them it's a bunch of particles, they say, oh, what do you mean? What are you talking about, Bill? What do you mean it's a bunch of particles? Yeah, that's what it's always been. Since the days of the Greeks, it's been a bunch of particles. There has never, in the history of human existence, any other proposal than particles. It's always been particles. You talk about waves, it's particles. You talk about magnetism, it's particles. It's done with particles. It's mediated, it's simulated with particles. You talk about field, particles. Energy, particles. Mass, particles. It's always been particles. Where have you been? There's never been any other proposal until I came along and said all atoms in the universe are physically interconnected. There's a single thread in the universe. That's a totally different setup. Until that came along, it's always been particles, both the official mathematical establishment, and the dissidents. They all believe in particles. There's not a single person on planet Earth that has ever come up with anything other than particles. So when you say, oh, it's a fluid, oh, it's a field, what are you saying? What is the field? What is the fluid? Particles. That's what you're saying. You may not like it because you never thought about what you're talking about, but that's what it's been. And that's what all these people used to say. It's particles, 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 particles. You won't get away from particles. And I'll beat it into your brain that it's particles. It's always been particles. Okay, here's the next group of people. More evidence, more proof for those who believe the ether is something other than bunch of particles, right? James Maxwell, ether medium for a propagation of light waves. Light must be a wave process in a medium rather than a substance. Well, what is the difference between a medium and a substance, dear James? Okay. And then he goes on and shows how the phenomena of polarization fits in with wave theory. Okay, great. Properties of the ether include all these things. Well, what is he talking about? If it's elastic, if it's got density, what are we talking about? Well, he's talking about particles, okay? And then he says he distinguishes ether from gross matter. Well, how is it different? I mean, we're talking about particles here and particles there. Dirac, another notion that came later, again, it's an ether. And what was it? A theoretical model of the vacuum as an infinite sea of what? Particles. Math physics today, virtual particles. That's what they're talking about. Excitations of the underlying fields. What are fields? Particles. But are temporary in the sense that they appear in calculations of interactions. The accuracy and use of virtual particles in calculation is firmly established, but they cannot be detected in experiments. I love that. They can't detect it in experiments, but it's been firmly established. Why? Because they're particles. Because they simulate everything with particles. So anyone who says that ether's not a bunch of particles, this is the homework you got to do. You got to tell me what it is in it instead. And don't tell me it's a field. Don't tell me it's a fluid. You got to come up with a physical object if you're going to use ether as a physical object. And it can't be the whole thing. If you're going to talk about the ether, we're going to talk about the whole shebang. You can't say, well, some vibrations of the ether here inside is what light is. You can't say that. Okay, because then you're talking about the particles that comprise the ether. You got that? Okay, let's hope that sinks in. Okay, and here we have Robert Laughlin, and again, I've mentioned this a couple times before, but here one more time. The modern concept of the vacuum of space, confirmed by every day by experiment, is a relativistic ether, but we do not call it this because it is taboo. This man with a Nobel Prize, hopefully he outranks you, so you better listen to him. He's saying that the vacuum that is used today by both quantum mechanics and general relativity is an ether. But they don't call it that because the word is a no-no. Ever since, they got rid of the ether word, they don't want to bring it back, but it's an ether. And why is this important today? Because space-time, as you will see, is an ether theory. Okay, we'll get to that in a second. Okay, here's the dynamic ether. You ever wanted to know what ether looks like? Okay, well, I can't show you what it looks like in one shot because it's always moving around. Remember that ether vibrates, meaning the particles of ether are vibrating. Here they are. That's the ether. You always wanted to know what the ether looks like. There it is. I made it visible for you. All that invisible stuff that's in the background, And you might say, well, light is the waving of the ether. Okay, so here's a waving of the ether, okay? But are we talking about the waving of the whole ether, the whole shebang? Or are we talking about, what are we saying here? We're saying that maybe it's just a few particles that are vibrating. Is that what the ether is? See, you either talk about the whole shebang and say the whole ether waves, or you don't use the word ether. You have to talk about the particles that comprise the ether. And otherwise, you got to tell me what the ether is. And so here's a static image of the ether, okay, for those, because some people believe that the ether is static and light moves through it, okay, and so here it is. That's the static ether. You might say, well, that's the ether. Okay, so now you have it. So you got to tell me what the ether is. And you can't say, well, ether is a bunch of particles because that's a definition. That's not a thing. Okay, you can't say then the ether vibrates. Okay, so either you point to the ether and tell me what the shape of it looks like, or you tell me what each individual particle looks like, and for that matter, you would have to tell me what encapsulates each particle. And here, let me show you an example here. Okay, this is a particle. Okay, it's white, and we don't care about the particle. We want to know what the black stuff is, which is the one that nobody wants to identify. Everybody wants to talk about the particle and say that's a particle of ether, or that's a field particle, or a particle of energy, or a particle of mass, or whatever. We don't care about the particle. We want to know what the black stuff is that contours, give shape to the particle. And the reason for that is if you have many particles, like in this case here, okay, for you to identify each one of those particles as a separate, discrete entity, it's got to be separated from all the rest. Otherwise, this would be a single block. And so we need to find out what the black stuff is. That's what we're interested in. That's what nobody can identify. And you might say, well, that's space. Okay, you got to tell me now what space is. And the question is whether space is an object, because you say space, but so far you haven't said anything. All you said is that's X. And so I want to know what that X is what is that black stuff? And you say, well, that's space. Is space a physical object? Is it finite? Is it infinite? And some people say space is infinite. Others say space is finite. We have all these versions out there still. After 10,000 years, we haven't resolved that issue. You have people on one side and people on the other side. They just use it any way they want, and you say, okay, so what is a space? Is it an object? Well, if you're going to talk about being finite or infinite, you're applying an adjective in physics. Remember, we're talking about physics, not ordinary speech here, okay? You're applying an adjective. You can only use adjective to describe objects. And so if you say infinite or finite, you're applying an adjective to a noun. You're treating space as a physical object either way. So it doesn't matter. And so assuming you say that space is a physical object, you got to show me the space, the shape of space. And okay, you say that's what the black stuff, that's what space looks like. Now you got to tell me what the white stuff is. What's contouring space? And hopefully you don't say that white stuff is an object too, because then I'm going to ask you what contours that. And we can go on and on ad infinitum. And that shows you why at some point the buck has to stop. You can't continue pushing the buck. Some point you got to tell me what contours it all. And you can't keep pushing it out into no man's land and say, well, I don't know what's out there. Then you don't have a case. In science, it's very simple, very straightforward. Space is that which doesn't have shape, meaning there's nothing outside of space, because otherwise it would have shape. Okay? And so space is that which doesn't have shape, serves as backdrop, if you could call it that, to matter, which is what has shape. Okay? So the objects like atoms and so on, they're all contoured by this space thingy, which is not a thingy. It's just that which doesn't have shape. And because it's that which doesn't have shape, it's not infinite or finite, because it's not an object. Nothing is a concept, not a thing. Okay, that's why it's called nothing. It's the opposite of thing. Okay, so thing is that which has shape, and nothing is that which doesn't have shape. They are antonyms. Nothing is what gives contour or shape to what does have shape. Okay, provides a contrast. And so something cannot turn into nothing, nothing cannot turn into something, therefore the somethings have always been there. The thread has always been there. The thread had no origin. There's no God that made it. If God made it, fine, he's in here with us. He's trapped in this prison together with us. Like I say, space is the largest prison never built. You can't build, you can't create, you can't design nothing. I mean, I do that every day. I do nothing every day. No, you can model, you can morph, you can convert something into something else, but you can't convert nothing into something. And you can't convert something into nothing like they do in quantum mechanics and general relativity. And so, yeah, we have differences of opinion there, differences of theories. Okay, here we have uh, final point here on this one. And this is how quantum mechanics again creates particles. They have this energy, negative and positive energy, I guess female and male. And somehow these morph into virtual particles. This is their theory. They say this is happening every day, that particles pop in from the void, and then these same particles combine because one is negative and the other one is positive, and they turn back into empty space, into vacuum. This is the theory that's out there. So yeah, they have creation of matter from the void, and they have matter turning into void as well. That's mathematical physics for you. Why? Because they're not interested in physical interpretations. This is all magic. This is not even magic. It's surrealistic. It has no bearing whatsoever in science. Okay? So for them to say that two particles turn into space, they turn into nothing, what do you mean? Are they still there as particles? And they say, no, they annihilated. Well, what do you mean by that? Well, what did they turn into? I mean, they annihilated, and what happened with the matter? Did 3D turn into no D? So these are the questions that they don't answer. They just said it annihilated, whatever that means. And then they say you should study math to find out what that means. It means that turns into a 0. And then the 0 turns into a 10. That's all math. That's got nothing to do with physics. Those are descriptions. Okay, so let's get into the subject matter today. And again, what I want to focus on is not the math. Okay, there's a little bit of math here, but I'm just going to use it to show you what the mathematicians are thinking or how they came to these ideas, not because we're interested in the math itself. The point here is to talk about physical interpretations, about mechanisms of how the universe works. Okay, that's the bottom line. And the issue here is space-time. You know, does space-time have anything whatsoever to do with how the universe works? We don't care about the math. We don't care about whether Einstein broke his head, you know, doing his variables and numbers. None of that is of any significance in physics. In physics, Einstein has to explain why the Earth doesn't fly out of the solar system. That's what he's got to do in physics. And if he cannot explain why the Earth or the moon or any planet for that matter, or any moon, any satellite, does not leave the solar system physically, what prevents it from physically leaving the solar system, if he cannot explain that, he has no theory. A description, a mathematical description, which is what these people do, is not a theory, but that's what the mathematicians call a theory. So they say, oh, the relativity theory. We're going to find out this so-called relativity theory is not a theory, it's just a description, because the theory is bunk, it's nonsense, it's poppycock. And so, in other words, the explanation they give you for why or how gravity works, that's nonsense. It's total nonsense. That's what we're going to go over. So again, the math is incidental. Okay, don't pay attention to the math. Here we go. We start with this fellow, and his name is Abbott. And Abbott is important in this whole thing because he wrote a book in 1884. And that book has to do with dimensions. Dimensions, as Americans call it, British call it dimension. I always use dimension. Anyways, he called it flatland. And there he talks specifically about dimensions. And what's important about this is that even to this day, this book, that's why I say it's the most important book of general relativity. This book is the one that's used to explain to you why we cannot visualize, why we cannot imagine space-time. Why? Because space-time is four-dimensional. Why can't you imagine it? Well, because we are unfortunately three-dimensional beings. We are stuck in three dimensions. And you say, well, what's that got to do with anything? Well, imagine if you were a flatlander, two-dimensional flatlander, you could not be able to imagine a three-dimensional world because you only can see your flat land, your two dimensions. You're a square, a triangle, or a circle. You can't see cubes and spheres and pyramids. And likewise, we cannot imagine the four-dimensional world because we're stuck in this three-dimensional world. That's the analogy, that's the argument, and it all comes from this book. That's part of it. The other part of why this is important, why it's the most important book in relativity, is that, special relativity, it's called special because it's a special case of general relativity. What's so special about it? It's gravity-less. There's no gravity involved in a special relativity. And that's the world of flatland, because flatland has no gravity. You can't fall in gravity because there is no down. Okay, so all you have is sideways motion, and so in a way, Abbott killed two birds with one stone. On the one hand, he essentially described why, many things about the dimensions, assuming that you live in flatland, you would not be able to understand the three-dimensional world. And the other one is that it's a perfect analogy for special relativity, which is, again, a world of two dimensions. You could say there's no gravity, okay, there's no down, okay, so this is where we start. And where this takes us is that in this was 1884, 1887, you had these two fellows, Michelson and Morley. They ran an experiment, actually a series of experiments, in which they proved that there was no ether. Of course, many dissidents to this day say, oh, there is an ether, you just misinterpreted the results, blah, 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 okay? So there's a lot of dissidents believe in the ether. The establishment does not, okay? So assuming there's, 10% of the people out there are people who are interested in the subject and they are dissidents, well, only 10% of them, if anything, believe in the ether. 90%, those who bow down to the establishment, who toe the party line, they do not believe in the ether, or so they claim. As you saw, Mr. Laughlin, he said they do believe in the ether, they just don't want to call it that because it's taboo, okay? Okay, so a fellow that came right after that, around those days, late 19th century, was Lorentz. And Lorentz essentially made popular what's called the Lorentz factor. And you see it there. It's that little equation there, gamma equation there. Gamma equal to 1 over square root of 1 minus velocity squared over c squared. C squared being the velocity of light squared. What that little equation does is say that as that little v squared, right? As that little v, velocity, your velocity, it approaches the speed of light, 300,000 kilometers per second. As it approaches that, 1 minus that ratio gives you a very small number. And that very small number, when you have 1 divided by a very small number, it gives you a very big number, meaning gamma is a very big number. And they use that gamma, they multiply it times time, and they say, oh, lots of time. They multiply it times weight, mass, right? And they say lots of mass. And they divide length by gamma, and they said, oh, length contracted to very small. And this is where the ideas of traveling at near the speed of light come, where you have length contraction, mass increase, and time dilation. Now this, again, this already was in the 1890s. In fact, it came before that. In 1887, you had this fellow Voigt who already put that little, the key part, which is that square root 1 minus v over c, right? He already came up with that, 1887. Why is that important? Well, because Einstein, a fellow named Albert Einstein, he was only 8 years old at the time. Einstein was born in 1879. So he was only 8 years old when this fellow Voigt, German, right? He already had this this square root 1 minus v over c. And so this length contraction was already debated way before Einstein published anything on special relativity and general relativity. We're talking about 20 years before that. And so what do I mean by that? You know, all these people, they worked on this. Lots of mathematicians were working on the speed of light and what happens if you travel at the speed of light. They came up with all these equations, and Einstein's the guy who took the credit, and to this day takes the credit for all of it. Everybody assigns all this credit to Einstein as if he was the only mathematician alive in those days. And they forget about all these. I mean, you talk to anyone on the street and say, do you know who Albert Einstein was? And they say, oh, of course I know. You say, do you know who Lorentz was? Do you know who Heaviside was? Uh-huh. They would know who I'm talking about. And so all these people came up with all these things. Einstein took the credit. That's my only point. But well, that's the first point. The second point is what you see there. When Lorentz came up with all this notion, they started looking at whether the ether existed, and they were trying to incorporate the ether within what they observed. They came up with these equations. They tried to justify the ether one way or another because, you know, these people believe strongly in the ether. They grew up with the ether, just like people today grew up with space-time, with black holes and Big Bang. Go talk to them and say there's no such thing as dark matter or dark energy or black holes or Big Bang. They'll kill you. And these people were no different. They were born with the ether, and you couldn't tell them that the ether did not exist. They said, what do you mean the ether doesn't exist? Of course it does exist. But Michelson and Morley proved that it doesn't exist. Well, let's accommodate that. Let's find out if that's true. And so they try to work around that to try to justify the ether at all costs because they believe strongly, this generation believes strongly in the ether. What they did was they entered the rabbit hole because they started working with time. They started playing around with time or with this gamma factor, okay, this Lorentz factor. And so, yeah, it started getting very weird because they started playing with time and they said, well, if we travel at near the speed of light, what happens to length? What happens to mass? What happens to time itself? And of course, what happened here was they forgot about reality and they were just concentrating on math. Why? Because measurement only has to do with math. In physics, we're not interested in measurement at all. We want to have an explanation of how the universe works. We want to know how gravity works. And these people say, let me measure it. So what if you measure it? I mean, you know, here, my famous trick, we let go of the pencil and it falls to the ground. So you measure something. You measure the weight, the mass, if you want, whatever. You measure the speed. You measure how much time. So what? Can you tell me why the pen falls to the floor, not to the ceiling? You can't tell me by saying mass. You can't tell me by saying, gravity. You can't tell me by saying, speed or time. You will not tell me with any of those notions what causes the pen to fall to the floor instead of to the ceiling. Okay, so this is the problem. We had mathematicians dealing with the problem, and they thought they were trying to figure out how gravity works by doing math. And that's where we stand today. To this day, nobody can tell you why that pencil falls to the ground. Not one person on Earth, except us. You know, here we do have an explanation, a physical interpretation, but we're the only group. And so what did Lorentz come up with? Well, he already had the notion of what is known as time dilation. Okay, this is essentially what he came up with. Okay, that you have a train going by, and you have a passenger on the train and someone an observer on the platform. And in the case above, we're talking about the passenger on the train. And if lightning hits the front of the train and the back of the train at the same time, the passenger will see the front of the train hit her first before the one in the back because he's traveling in that direction and light has a shorter time to travel to his eyes. Okay, so that's the notion from the passenger's point of view. How about the observer on the platform? Well, for him, it happens simultaneously because he's equidistant from both points, the front and the back of the train. That's essentially it. What this did was introduce the observer into physics, into, well, mathematics, as we call it, okay? Because now people were concerned about what you perceive. Why? Because they were talking about measurement. So, well, you're measuring something and I'm measuring something different. Well, that's because you're moving at the speed of light. And so if you move in this direction, I move in the other direction, we're going to have different measurements. And we have to account for that in our measurements. It all had to do with measurement, measurement, measurement. Nothing to do with physics. It has to do with descriptions, with calculating stuff. We still don't know what causes gravity, but these people are talking about, time dilation, mass increase, length contraction, all this nonsense that they came up with. And just to rub it in, here we have Poincaré and Henri Poincaré, and he essentially enunciated the principle of relativity, also given to Einstein. And Henri was quite angry about that. He said, look, we worked, all these mathematicians, we worked for couple decades at least, 20 years, and this newbie, he comes in there, he takes all the credit for it. He's the creator of special relativity. He's the creator of time dilation, all this stuff, when we've talked for 20 years about this. And so, yeah, he wrote a paper there. Actually, he gave a speech, but he wrote the paper in 1904. Remember the annus mirabilis that Einstein had in 1905, 1 year later, okay? And here we're talking about Poincaré. He came to the United States. He gave this speech in St. Louis, and it's called the Principles of Mathematical Physics. And what I liked is in there, one of the headings is the present crisis of mathematical physics. Sounds like the year 2022. We're still with a crisis in mathematical physics. Nothing has changed in over 100 years. And so, yeah, he enunciated Poincaré enunciated the principle of relativity. That's not Einstein's. And he says the following. He says, concerning the ether, he says, the ether is how its molecules are disposed, etc., etc. And then in that same paper, he says, the atoms of ether. What is the ether? What did the etherists believe in? They believed that it was a bunch of particles, atoms, molecules, particles, points, whatever you want to call them. Okay? So the ether was a bunch of particles, a body, a fluid, a field, whatever you want to call it. I don't care. It doesn't matter. It doesn't change anything, because fields, waves, vortices, energy, all these words mean the same thing. They are a standalone. They are standing for lots of particles. That's what they're talking about. It's always been simulated with particles, and it can't be any other way, because mathematics can only put a value in an equation, and that value has to be represented with a single point. For example, a field. What is a field? Bunch of points. And when you talk about what's the strength of the field here, they're talking about the strength of the field at that point, at that location. And they designate it with a point, with a dot. That's why it's always been dots and points and particles. Nothing's changed. The only thing that's changed, when quantum and relativity also came later on, they turned those so-called particles into abstractions. They got rid of the particle altogether. They said, well, what is a particle? It's a vibration of a field. It's the excitation of a field. You're seeing the hump of a field, and that's a particle. So what is a particle? A field. And what is a field? A particle. No different. They're synonyms. Okay, just values that mathematics has invented to try to give some physicality to their equations. That's all it is. Okay, so here we have another fellow who came around the same time, and his name was Minkowski. And what did he come up with? Well, he came up with a notion of space-time. In fact, there's a debate. Some other people lived in those days that also talked about space-time, among them Poincaré. Okay, but he says in this paper he published in 1908, Space and Time, he says, the views of space and time which I wish to lay before you have sprung from the soil of experimental physics. Again, all these people thought that with experiments they were doing science. Okay? No, science is not about doing experiments. Science is about explaining rationally. You have to explain, give me a rational explanation for a phenomenon. That's physics. But these people said, I'm going to do an experiment. So what? Here, I'll do an experiment for you. I'll let go of the pen. There it goes. I let go of the pen. It fell to the ground. How many more times should I do it? That's gravity. And now you got to explain it. To say that you're going to do an experiment, what more experiments do you want to do for gravity? You got to explain it at some point, not do experiments. But these people believed in experiments, and to this day, people believe in experiments. They think science is about doing experiments. So do an experiment. Let go of the pen in your house. Everybody today, go ahead and let go of a pen in your house, and you'll find out it falls to the floor. Unless there's, some magnet out there that's holding it up. It'll fall to the floor. How many more experiments do you want to do? What's the purpose of doing more experiments? Now you got to explain it. Why does it fall to the floor? What comes in contact with a pen is the question. Because if you don't put something in contact with a pen, you are doing black magic. You're saying that spirits are bringing it down. You can't say, well, mass and the energy in the field. No, because those are concepts. We need a physical object. You can say that a tree pulled it down. You can say a rope pulled it down. You can say, a wire pulled it down. That you can say. You can say a dog pulled it down. You cannot say a field pulled it down, or energy pulled it down, or mass or gravity or whatever. Okay, you can talk about particles if you're talking about real particles, Then you can say that particles pushed it down. Okay, that's acceptable. As long as you talk about particles, okay? You would have other problems, but that's beside the point. The point is you can use particles to push the pen down. You can use that. You cannot say a field brought it down or energy brought it down. Those words are concepts. You can't use those words in science. That's like saying love pulled it down, because love is attractive, I guess. Anyways, he says, henceforth space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two, space, time, will preserve an independent reality. And so that's more or less 1908. That's when this notion of space-time started taking shape, okay, in the minds of all these mathematicians. And what were they talking about? They were talking about length, width, and height, and time. And they converted time into a dimension, which is what Abbott had said, more or less. And he talked about dimension. He didn't talk about time. But, these were the days where time became a dimension because people were trying to measure time. They were saying, well, what happens if you travel at the speed of light? Well, then what happens to time? Well, it's stretched. It dilates, and so that's when they got into trouble because the semantics was not up to par. And to this day, it's not up to par. So they talk about time dilation. You say, what do you mean time dilation? Are we stretching time? Well, you're not supposed to take it so literally. So what did you mean? Okay, we're going to talk physics. Let's talk physics. Okay, and then this fellow came around in 1915. He wrote his paper, Albert Einstein, and he said gravity is warped time. And he says it's time that is bent, it's warped, and that's what prevents the moon from leaving the Earth, or the Earth from leaving the solar system, or Jupiter from leaving the solar system. Warped time. And you say, Bill, you're making fun of these people. You're not being serious now. No, I'm being deadly serious. This is the explanation you get for why the Earth doesn't leave the solar system. That there's a depression, and the Earth is rolling around the edges of this depression like a ball around a roulette. That's the physical interpretation. That's the mechanism they illustrate for you, okay? You don't believe me? Here it is again. I didn't create this, okay? Here it is, okay? That's the moon, and it goes around a depression. What is that depression into? What is that blue stuff with all these white lines going through it? Well, that canvas is known as space-time. This is you could say a three-dimensional version of space-time. They say they cannot produce a four-dimensional one. Fine, we'll concede for the sake of argument. But what we're interested here is in the mechanism. They're saying the moon doesn't leave the solar system or doesn't leave the orbit of the Earth because it rolls around warped time. That blue canvas with white lines, that's space time. You're bending time. They even say, they tell you that gravity warps time. They say these words. So I'm not inventing anything. I'm not putting words in their mouth. Okay, this is the mechanism that they explain. What do they respond when you say that to them? Well, they say, Bill, you're not supposed to take the analogy so literally. Well, if I don't take it so literally, what have you explained? What is the mechanism? Why doesn't the Earth leave the solar system? Why doesn't the moon leave the solar system? If that was just an analogy, whatever you meant by that. I mean, I need to know what comes up against the skin of the Earth, and you're telling me it's warp time, that portion of space time. Warp time is coming up against the skin of the planet. That's what you illustrated. And then when I say, you mean you have warp time? And you say, we're not supposed to take it so literally. Then what am I supposed to, I mean, I'm asking for an explanation why the Earth doesn't leave the solar system. I have to take it literally, whatever you give me. And so here it is. This is the answer they give you, okay? Okay. Says, understanding gravity space-time is like a rubber sheet. Massive objects distort the sheet. And wait, student says they distort it because they're pulled down by what? And the teacher said, my God. Space-time is like this set of equations for which any analogy must be what? An approximation. What does an equation have to do with this? And so the people who created this say, oh, that's so boring. No, it's not boring. It's irrational. The guy is irrational. He's trying to get away by saying, look, you got to study math to understand what we're saying. If I studied all the math in the world, all I would have is a description. I want an explanation of why the Earth doesn't leave the solar system. And if the guy says it's because it's bending, the Earth is bending the rubber sheet, and that's why the moon doesn't fly away, and the sun is bending the rubber sheet, and that's why the Earth doesn't fly away, then that's analogy is what that's what his explanation is. He can't later on deny it and say, well, you're hanging on every word that I say. Of course I do. It's got to be literal. Physics is literal. Okay, you can't BS your way with equations and numbers and variables. That's where the problem is. These people are giving you a description and selling it to you, like a used car salesman or a guy who sells you some snake oil, and it's trying to pass it as an explanation. And when you focus on the explanation, you say, well, it's just a description, mathematical description. You got to take math to understand what we're saying. You got to look at the equations. Those are descriptions. I want an explanation. So they don't have an explanation for gravity because when you call their bluff, they say you're not supposed to take it so literally. That's the answer you get. Okay, so be aware that's what it is. And that it is a description is certified here by Mr. Stephen Hawking. Okay, and here he says, an event is something that happens at a particular point in space in a particular time. It is often helpful to think of the four coordinates of an event as specifying its position in a four-dimensional space called space-time. It is impossible to imagine a four-dimensional space. That's out of his book, A Brief History of Time, bestseller, okay? And so he's saying, look, this is all a concept. This is not an explanation, okay? He just thinks that it's helpful to think of it as a four-dimensional, as a four-coordinate event. What is that? That's a description. He hasn't told me why the Earth doesn't fly out of the solar system or why he doesn't fly out of his wheelchair there. Okay, so this is where we stand. They have descriptions. They're selling it to you as an explanation. There is no explanation for gravity, or like Mr. Toth, Victor Toth said a couple weeks ago, when we analyze him, what did he say? He says, we're still investigating. Yeah, they're going to be investigating another 400 years because they have no clue whatsoever what causes gravity. And that's what people want to know. The layman wants to know why that pen falls to the floor, why the baby spoon fell to the floor. They don't want you to give them some equation that describes how fast it fell or what the weight was. People want to know the mechanism. And that's where mathematical physics fails. And space-time is not going to help you. Space-time is a four-coordinate description of gravity. That's all it is, okay? And just in case, to top it off, we have Mr. Eine, and just want to make sure that we understand that he still believed that space-time, it has to do with the ether, okay? Says, we may say that according to the general theory of relativity, space is endowed with physical qualities. In this sense, therefore, there exists an ether. According to the general theory of relativity, space without ether is unthinkable. He said that in 1920, 1 year after his theory was so-called certified by Arthur Eddington when he did his picture of an eclipse, and he found that a star behind the sun, he could see it. Why? Because he says the light curved around the sun. That's what this poor guy, Arthur Eddington, concluded, that light was bent, as they say today, or warped. It never occurred to him that what he's talking about, not bent, but deflected. Because if he's going to talk about photons, he's got to use the right language. He can't say light is bent. He's got to say light is deflected because he's talking about particles. What is mathematical physics about? Particles. It's always been about particles. They never left the particles. Okay? So yeah, that's the first problem. The second problem is we have a different explanation for that. We don't need the little photons to curve around the sun to be deflected by the warping of space-time, which is a concept. Again, they use space-time as a physical object. When you put it to them and say, are you saying time is warped? Because that's what they're telling you. And they say, well, you're not supposed to take it literally. Then what have we learned? we're running around in circles. We're warp space, I guess. Depression. Okay, so what are my conclusions for this space-time thingy? Here's a rundown. Space-time resulted from the necessity of discarding the 2,000-year-old ether. Towards the end of the 19th century, the ether was dying, and a few people tried to save it at the beginning of the 20th century, but they had no luck. Eventually, the ether went away. Really, the word went away, but the concept stayed, because even to this day, like Mr. Laughlin says, what they deal with is the ether. They just don't call it that because it is taboo. But space-time is an ether theory. What is ether? A bunch of particles. What is space-time? Well, I think you have it there. Dissonance have never offered an alternative to particles. That's the first thing you need to know. In math, physics, and among all dissidents, right? Space is made of particles. Some say space is infinite. Others say it's finite. And whenever you use two adjectives like those, you're talking about a physical object. Adjectives can only be applied to objects. But one of the main points is that space-time introduced into math physics the false continuity, the fake continuity. Why? Because they talk about the space-time continuum. See, with discrete particles, you don't have any continuous of anything. Everything is discrete. Everything is segmented. And somehow you had to tie it all together if you're going to talk about action at a distance. And that's one of the things that general relativity introduced for the first time in mathematics. They introduced continuity, the space-time continuum. In other words, space-time is this rubber sheet that extends all the way from the sun to the earth, from the earth all the way to the moon. So it's a continuous entity, medium. And so now you can talk about action at a distance, because you say whatever the earth does here, it affects the moon over there, because the vibrations move through the space, through space-time, through the rubber sheet, right? They treat it as a rubber sheet, space-time, it's warped, warp time. And when you confront them, they say, well, it's just an analogy. You're not supposed to take it literally, okay? But general relativity space-time is made of points known as events. That's why it's an ether theory. Each point, I mean, what is ether? A bunch of particles. What is space-time? A bunch of points. What is a point? An event in space-time. That's what it is. So space-time is an ether theory, an ether proposal. It's made out of points, but somehow it's continuous. You see, so they covered all the bases. They said it's discrete, but it's also continuous. Okay, meaning it's all connected. Okay, so they needed to cover both worlds so that they could explain gravity to you. Okay, they say, why does the Earth affect the moon? Well, because it's a continuous rubber sheet. Rubber sheet of what? Of time. Time is a physical object. You're not supposed to take it literally. Space-time is an irrational mathematical theory, meaning it's not a theory at all, it's a description that states that the Earth doesn't fly out of the solar system because time is warped. That's what space-time is all about. They call it a geometric theory of gravity. It's got nothing to do with geometry because geometry, first and foremost, is about figures. The zero-dimensional point, the one-dimensional line are not figures at all, but those are the foundations of geometry. We covered that in last couple sessions. So mathematical physics, especially general relativity, is founded on this notion of geometry, which is in itself founded on irrational proposals, which is the zero-dimensional point, meaning location, and the one-dimensional line, meaning itinerary. Okay, and so that's what geometry is, and space-time or general relativity is supposed to be a geometric theory of gravity. What is it? Space-time. And what is space-time? Time, which is warped, and that's what they say gravity is. I hope you got all that. It's going to be on the test on Friday. Okay, let's move on to questions and comments people made since last time. We had several of these. I'm not going to cover them all, the questions people made. Comments, if I miss your question, your comment, please put it up again. Okay, one fellow says, no one knows how or why anything is what it is. And that brings to mind the famous Latin saying says, ignoramus et ignorabimus. We do not know and will not know. So that's been around for quite a while, okay? And yeah, ignorant people say that because the first thing you should know is that in science we do not use the word know. Okay? Knowledge belongs exclusively to religion. When you know something, it means you believe it, you're certain of it, and that's you. Okay, it doesn't mean I believe in it or that I certify it or that I approve it. Okay, if I'm your boss, for sure I'm not going to approve it. Okay, so when you know something, it's because you believe it. You are certain of it, you meaning. You say, well, so are the mathematicians. Well, yeah, so now you have 2 people who believe in it, 3 people, 4 people. Is it a question of how many people believe in it? I mean, is God true? Does God exist? God created the universe? Well, you believe in it. You may say, you know that God exists. Well, the other guy, the atheist, says God doesn't exist. So knowledge is not a part of science. You can't use the word know in science. Every time you use the word know, you're talking about religion. Okay? So please don't know anything. Okay? In science, we explain. We do not know. We explain so that you understand, not that you believe. In other words, know. In other words, believe. Okay? Okay, fellow says, I can't imagine... no, I said the other day, I said, you can't imagine a 1D object, okay, the 1D axis, and he says, your argument also applies to 2 dimensions, okay? No one can imagine a 2-dimensional object that has no depth. That's illogical. 3 dimensions is the minimum for physical existence. Well, there's a 2-dimensional object. If I can illustrate it for you, certainly I can imagine it. I mean, what problems do you have? Are you blind or what's your problem? I mean, there you have it. It's a 2-dimensional object. Obviously, I can imagine it because I drew it. I mean, the 1-dimensional one, can you illustrate the one-dimensional one like I illustrated the two-dimensional triangle? And the answer is no. You can't illustrate a one-dimensional anything or a zero-dimensional anything. Okay? So yeah, I illustrated it, but let's go with the fallacies. This poor fellow suffers from all kinds of fallacies. Okay? Here it is. First, the definition of object. Okay, an object is that which has shape. And two-dimensional whatever has shape. One-dimensional or zero-dimensional whatever don't have shape. There is no shape there to begin with because you cannot produce the shape out here. You might say, well, I can see it here. Well, if you can see it, you should be able to put it out here. I mean, I can imagine a two-dimensional triangle and I put it out there and prove to you that I can imagine it. Prove to me that you can imagine a one-dimensional whatever. Okay? And equates objects with existence. See what he did here? He says three-dimensional is the minimum for physical existence. We're not talking about existence. Why did you bring the word exist into this discussion? See, again, all these people confused, just like David Hume and Immanuel Kant, they believed that there's no difference between an object and exist. Object and a thing and existence. They said it's a synonym. That they didn't know what the word existence added to the word object. And what it adds to it is location. They never figured it out. An object with location exists. An object without location does not exist. So if you have a vision in your head of a three-dimensional table, you might see it in 2 dimensions. That table does not exist because it has no location. There is nothing, there's no table inside your head. What it is, you have electrical, chemical processes going on in there that create this thought, this vision. Okay? But out here, the table exists. If you see it there, why? Because it has location. That's the definition of the word location, the word exist. Okay? So this fellow, again, he confuses existence with location. That's one issue. Then 2D has shape. Anything that's two-dimensional, square, circle, they have shape. So that's what an object is. An object is that which has shape. Do not confuse that with the notion of ordinary speech, the notion of object of ordinary speech, which is that which you can see or touch. That's not what we're talking about. We're talking about the scientific definition of the word object, that which has shape, not that which you can see or touch. You can't see or touch the table that the Klingon has on the other side of the universe, but that table is an object. Hopefully the word table is always an object, referring to the furniture, right? Okay, and again, the 1D doesn't have shape, and objects that exist are 3D and have location. That's what existence means. Exist means an object that has location, and for that you have to have 3 dimensions. There is no such thing as a 2-dimensional object that has location, or an object whatsoever that is 1-dimensional or 0-dimensional or 4-dimensional or greater. Okay, a lot of questions on God. Fellow says, rational science, none of that these days. Big Bang is equal God said there be light, and bang, light became. Okay, and to think it took a lifetime for the most renowned atheist to come to the conclusion that where there is a grand design, there must be a designer. So he says that because you have a grand design, in this case the universe, right? The stars, the galaxies, all that stuff, there had to be a designer for all that. Okay, you have a grand design, you have a grand designer. Okay, so let's follow his train of thought. Let's see where it leads. Okay, here we have it. Okay, God is also a grand design because God is almighty and he allegedly created the universe, right? He's all-knowing, right, etc. So pursuant to this fellow's logic, there must be a designer that designed God. Okay, and so the question is, what's on the other side of that magic wand? Is that God's father? Is it God's mother? Is it a magician, an angel? Okay, who created God? Who designed God? He's also grand design. So all these people, they fail logic at the basic step. I mean, if the guy's going to say that grand design requires a designer, well, then God requires a designer. He can't say, well, for that, I'm not going to use a designer. God has always been around, which is one of the arguments out there. Very simple. We don't need God at all. We can say matter has always been around, which is what we say. Matter has always been around, and that's easy to prove because matter cannot convert into space, and space cannot convert into matter. Something cannot convert into nothing, and nothing cannot convert into something. Very simple. We're done. We don't need God at all. Okay? Get rid of God. Okay, another fellow says, watch. Oh, no, this is in line with that as well. The watchmaker analogy. They say, the designer, the creator. Okay, and so they use this watchmaker, that a watch had to have a watchmaker. You find a watch on the sea, on a beach, and you see it with all these intricate, things in there. And you say, well, this could have been made by nature. This had to have a maker, a designer, a creator, an intelligence, or a human who toiled and worked on it. Okay, and I've got that in my book, and Why God Doesn't Exist. Okay, and these are just in general terms. It goes into a little more detail, but these are the main points. Is a watch a living entity? Because they say God created humans. Well, can you say that creating a watch is the same thing as creating a human? Are those similar processes? That's the first issue you should consider. Is it time to compare a living being like man to a watch? Did a rock have a rock maker? You find a rock on a mountain. Whoa, a rock. I mean, you find a watch, you say, well, that had a watchmaker. Well, did a rock have a rock maker? Okay, or is it just too blunt to be able to say that that required God to make it? Could it have been made by the earth? Okay. So again, if you're going to say watch and tree and dog and everything else, well, is a crystal made by God, or was that made in some other way? Okay. Did the rock maker climb the mountain and place the rock up there? Okay, did he take all that trouble? Okay, and then you have Uri and Miller. What was it? I think 1951, 1952. They attempted to create life, and they failed. They were able to create amino acids. They took some, I think, methane, and they had it in some kind of flask. They gave it a shot of electricity, and a few days later, they had some amino acids form in there. Now, amino acids is not life, okay? So that's straightforward, okay? But it's one of the components of DNA, so you can say that, it's one of the components of life. And they were able to create that, like creating one of the missing links in the whole chain of life. And in that sense, you could say it's an important experiment. But they were not able to create life. What do I mean by that? Well, then we continue here. So far, humans can't create life. Therefore, we have evidence that intelligence can't create life. Not the opposite. We can't say intelligence created life because so far intelligence has not been able to create life. That's the proof, that's the evidence of what we have out there. Humans have the highest intelligence available in the universe. And a lot of people roll their eyes and say, oh my God, what is he saying? Yes, we have the highest intelligence. Mother Nature has ran out of blessings to give us. We are the highest intelligence possible in the universe. And of course, when we reach this level of intelligence, it's the end of man. So it confirms once again that we are the last humans on Earth. We don't have super intelligence. There's no such thing as, no such monster as super intelligence. So we have more and more and more and more intelligence. What intelligence do you want? I mean, if you're shortchanged, you got to complain to your mother. Sue her. I don't know. She made you like that. But, there's no such thing as super intelligence. You should be able to understand anything that any human wants to explain to you. If God Almighty or the devil himself comes here right now, he should be able to explain gravity to you, what causes gravity, and you should be able to understand it. What more intelligence do you want than that? I mean, what kind of intelligence are you expecting? And people say, oh, all this super intelligence that the Klingons have out there. There's no such thing. Humans have the highest intelligence that can evolve in any planet in the universe. When they reach a high level of intelligence, that's about it, because humanity dies at that point. It dies wherever it's in the universe, it doesn't matter. Finally, it dies because the population pyramid overturns, and because of that, the economy collapses. The last dynasty of humanoids, or what is it? Hominids, etc. Okay, therefore, there is no evidence that intelligence designed or created life. We have no evidence today that life can be created by intelligence. Okay, so for those of you who are religious, who've been taught in Sunday school that there had to be a designer who created life, very simple. We have no evidence that intelligence can create or can design life. Very simple. We can probably understand it. Create it is a different thing. And by creating it, I mean in the lab. Of course, we can create life through a female. That's not creating life. That's just reproducing, like any animal out there, or even plant for that matter. Plants put the seed down, a new tree grows. Now we're talking about creating it in the lab, artificially, okay, but with your hands, not through your body. Okay, another issue related to God here. It says, you say that there is a problem with accepting that God was always there, since this movie starts with frame number 2. Yeah, because if God is already there, we don't know how God came into existence, right? So we don't know what happened in frame number 1. When you put and say God created the universe, all you're doing is starting at frame number 2. I want to know what happened in frame number 1. That's got to do with Big Bang, because Big Bang also starts at frame number 2. We have no idea what happened at frame number 1. How did this singularity, this densely packed whatever, where did that come from? So we want to know what happened in frame number 1, not in frame number 2. And mathematical physics conveniently stops at frame number 2. Okay, and so if I says, what's the problem? If your quest is to find what happened to the beginning, we don't need to know who was there, but what he did. This is how religious people are so irrational. They don't even ask these questions. It doesn't bother them at all. They don't want to know how God came into being. He says, well, that's not important. We want to know what God did on that day. Poor fellow. Again, he's got to complain to his mother. Some people like that, they say, we'll never know anything because they don't understand anything. You didn't tell us what the beginning exactly you're talking about. Yes, I have told you that, but you missed it. I'm talking about how matter came into being. In other words, how did space, nothing, vacuum, turn into something, objects, matter? That's what we're talking about. That's what I talk about when I say the beginning. I want to know how the first atom came into being. Okay, do we have that? That's the beginning. Okay, and so here's the answer, formal answer. Who told you first that there was a who? Where did he get this who deal? Okay, he invented that. That's an irrational proposal to say that there was a who. And again, intelligence cannot design life. We have no evidence of that. We are the highest intelligence in the universe. We cannot create life. Space, in other words, nothing can't turn into matter, something. And matter, something can't morph into space, nothing. Okay? Matter was always there. No one created matter. Only in the religion of mathematical physics and in traditional religions do they propose creationism. In other words, Big Bang. In other words, that matter came into existence. That's what we're talking about here, okay? Okay, let's get rid of this. Give me a second here. Okay, another fellow says, to exist means, as showed in the video, to have a physical presence. Okay, good. He said, meaning me, right? No one has defined what exist means in the last 10,000 years. Exactly. Then he accepts it means physical presence. I mean, some people are total dense, totally dense. What are you going to say to this poor fellow? He doesn't have a brain. I guess he picked up the scarecrow's brain, when the scarecrow left Oz. He doesn't realize, I mean, where did he get this definition of physical presence? Did he find it in a dictionary? I mean, he likes it apparently. He says, to exist means, as showed in the video, to have physical presence. Good, I like that. Okay? Then he accepts it means physical presence. Yeah? But he says, no one has defined that. I say that no one has defined exist when I say it's physical presence. So how come I say that no one has defined it if it's defined as physical presence? So here my answer to this poor fellow. Oh, poor fellow. He's just not even close. I mean, these are the answers. Where did you get that definition? Please look up the definition of exist in any dictionary on planet Earth, past, present, or future. See if you can find this definition, physical present, that you love so much. Tell me in which dictionary you found that definition. In other words, exist is equal to physical presence. Okay? So that's homework for you. If you can answer that question, hey, I'll give you $1 million. Okay? Is that fair? I'll buy you a beer. If you can tell me where you got that definition, where did you hear it? Where did you find it? In what dictionary? I want to find it. Okay? That's the answer to you. When you figure that out, you'll figure out everything. what mental problem these people have. Okay, here's I think the same fellow. If I say George X exists, would you respond, how do you know? No, only an idiot would ask, how do you know? Okay? That's not the question. The question is, please define the word exist. That's what I would ask you to that's the question I would ask you. Don't say, if X exists, how would you know? It has nothing to do with knowledge. The word knowledge, the word know belongs to religion exclusively. It has no place in science. Knowledge is exclusively religion. When you know something, it means you got a religion. You believe it. That's all it means. Okay? So we don't use the word knowledge, the word know in science. In science, you have to define the word exists, and then we'll know whether George exists or not. We just follow the definition. We apply the definition to George X, and we'll know, right? Meaning we can make the assumption that George exists because it follows the definition of exist, which is what? Physical presence. I wonder where he got that definition. What dictionary was that from? Is he an object or a concept? Okay, if George refers to an object, then George may be said to exist if George has location. Okay? If George refers to a concept, right, if that's what George means, right, then the definition of exist makes it irrational to say that George exists. Okay, so I hope that's understood. Only objects can exist in science. You cannot have a concept that exists in science. You cannot say that love exists, not in science. You cannot say intelligence exists. You cannot say data exists. You can't use concepts and say, you cannot say energy exists or a field exists. No such monsters in physics. In physics, only objects can be said to exist. You can say a tree exists. You can say a dog exists. You can say a house exists. Why? Because they have location, physical presence. You cannot say that a house that you're imagining exists because it has no location. House is an object, but if it's the one that you're thinking of, that one doesn't exist. It has no location. No separation between your house, the one that you have in your brain, and my chest, because your house has no location. Okay, another fellow says, then he says, same fellow says, then he says, we don't define objects. Why not? Who told him that? Yeah, we don't define objects. We point to them. You have the Klingon. He comes and visits us, right, from Klingon land. He wants to learn your language, and you say, well, tree. What do you mean tree? What is tree? And the way you are going to teach him your language, and when you're going to teach him the word tree, is by pointing and saying tree. You don't say, well, look, a tree is this object, right, that has leaves and has branches and is brown, grows in summer, and he has no idea what you're talking about. You have to point and say tree, then he knows what the word tree means. That's how we present objects in physics, in science. Okay? The description is irrelevant. Okay, we don't care about descriptions. So no, we don't describe. We point and name. That's how we do it in physics. So we don't define objects. As soon as you start defining, you're talking about a concept only. Okay, concepts we define, objects we point to. When we see a new device of some kind, what do we say? We say, what is that? Then we wait to hear what it is, a description. He's got all kinds of mental problems. I don't know, this poor fellow is completely out of it. No, absolutely not. Only irrational folk wait for a description. Okay? Now, first of all, he's confusing ordinary speech with science. That's his main problem there. Okay, and yeah, if you're going to confuse, you're going to use this notion of ordinary speech, which is see and touch, and you say, oh, that's a computer. Well, oh, what do you mean? What is a computer? And well, it's this thing over here, and blah, 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 you know? Now, the way it is, you point and name. That's how we present objects in physics. That's the scientific version. Okay? The see, touch, let me see it, let me touch it, describe it, that's all ordinary speech. He doesn't understand that. Okay? Well, it says, when we say God, we mean the being personality that created everything. Being personality. Split personality here. We have being on one side, personality on the other. It looks like we're talking about two different things. Being is an object, personality is a concept. Okay, let's see. We are then talking about a person. Okay? We are not talking about an object. So he's saying that God is not an object, but God is a being. Okay? We are talking about a person, but he's saying person is personality, and personality is not an object. Well, first of all, it's just absolute, utter nonsense what this poor fellow's got in his brain. It doesn't have much between his ears. Being is always an object, always a thing. You look up the word being, it says a living what? Thing. A living thing. What is a thing? That which has shape. That's what it is in science, not in ordinary speech. In ordinary speech, it's that which you can see or touch. In science, it's that which has shape. So either God has shape or God don't have shape. One of the two. Can't be both, like in dualities of mathematics. No, it either has shape or it don't. Okay, just that simple. Black or white, no gray. Okay, so if God is a being, then we're talking about a thing, and God has shape. That's what we're saying. If God don't have shape, then God is a concept. And in that case, you can't even talk about the existence of God because only objects may be said to exist if they have presence, location. Okay? And it is irrational to propose that concepts such as personality created matter. Because if God is personality, as God is not an object, God is a concept, then concepts don't create objects. Don't design objects, I mean. Okay, so you can't have it both ways. If God is a concept, if God is not an object, God is not a thing, meaning he's an abstract concept, then God could not have created the universe. Because that one you really have to explain how love created the universe, or how intelligence created the universe, or how data created the universe. What does that mean? Please explain the mechanism of how this concept created matter. Okay? And so, yeah, this is where these religious people fail completely. They have no rationality whatsoever. They never are able to explain to you a mechanism. And that's why what this other fellow says, we know nothing, we'll never know anything. Yeah. Religious people. In science, we don't know. In science, we explain so that you understand the mechanism. Okay, that's how we do it in science. Okay, here's another fellow. He says, science is a particular type of study. The purpose of that method is to arrive to results pertaining to the advance of knowledge in that field. Again, the word knowledge. These people think science is about knowledge because they found the word science and comes from Syria, which meant knowledge. No, the Latins, the Greeks, all these people failed completely. Science has nothing to do with knowledge. Okay? It's not accumulation of knowledge, and it has nothing to do with studying. What if you study all week and you learned nothing? You got a 0 on the test on Friday. So just because you study, you're a scientist? Anyone who studies is a scientist? So studying is the wrong word to define the word science. You can't use the word study to define science. You can't say science is the study of. That's irrational. Okay, because anyone can study. Does that mean? I mean, even a baby can study. So the baby is a scientist because he studied. And knowledge is equal to religion. Okay, anyone using the word knowledge is talking about religion. You're talking about what you know, what you believe. Belief is opinion, and it's got to do totally with religion. In science, we do not have opinions. We do not have beliefs. We do not know. In science, we explain so that you understand, not so that you believe. And science attempts to explain things. Science, he said that, right? Science attempts to explain things. And science does, but not mathematics. And he's referring to mathematics. Mathematics does not explain. In fact, it has no explanation whatsoever. And they don't claim to do explanations. And here's proof. Here's evidence. Here's for your knowledge. Okay. This is Richard Feynman. The more you see how strangely nature behaves, the harder it is to make a model that explains how even the simplest phenomena actually work. So theoretical physics has given up on that. In other words, they don't explain. And what does this professor say, Donald Simonek? He says, science doesn't explain, science describes. And you have to replace the word science with mathematics, mathematical physics. They do not explain. We have no explanations for anything emanating from mathematical physics to this day. We have no idea, according to mathematics, right? How gravity works. We have no idea from them how magnetism works, what light is, how electricity works, how an atom works. We have no explanations whatsoever from mathematical physics. So no, they do not explain. We explain in this site. Here we explain, but outside this site, no one explains anything. Everybody just does descriptions with particles. Particles is what everybody uses, and you cannot explain a single phenomenon of nature with particles. That's where the problem is. You got to get rid of the particle hypothesis. Okay, here's another fellow. He says, we can define all words to a certain degree, just like all things can be described to a certain degree. The way he puts it, meaning me, right? We can claim that all words do not have a definition. Well, the issue is that in science we do not define every word in the dictionary. We do not have to. We define only those words that make or break our theories. We're going to give a presentation, a dissertation. We have to define the key words in that dissertation. Those are the words we have to define. And in the case of physics, the foundations include the number one word without which you can't do physics, and that's the word object. You need to define object. No one has ever defined the word object in science, in physics. Okay? No one. Okay? First person that not only defines it is me, but I defined it and I did something even more important, which is understand the importance of defining the word object. You can't do physics without objects. You cannot give a physical interpretation without the word object. You need absolutely to define the word object in physics. And that's the first thing, because all these people are trying to give a physical interpretation on the one hand, and we say, but you're using a concept. Well, you're not supposed to take the analogy literally over and over and over again. That's what they say. Okay, no, if you're going to give a physical interpretation, you need to define the word object. You can't do physical interpretations without object. And then you have to use the word exist, because you can only do it with, if you're going to explain the real universe, you have to explain with objects that exist. And so you need to know what the word exist means, and yeah, it's object that has location, physical presence. Okay, and so here's the answer to this fella. And here it is. We don't define all objects, all words in science. The words that are required are the ones that make or break our theories. We don't define words to a certain degree either, like a gray area, like saying, well, I defined it to a dark gray. No, it's got to be black or white, on and off, yes or no. Not one scientist has defined a single word needed to do physics, specifically those that laid the foundations of physics. Specifically, well, I can name several of them, but the word object, the word exist, you need to define what location is, you need to define what distance is before that, because one of these is based on the other one. It's a comprehensive set. You need to define object. Then you need to define distance, which is the separation, qualitative, not distance traveled, but qualitative separation between two objects. You need to define location, which is the set of distances from one object to all the rest. That's what it is in the universe. Okay, that's what it is for physics. And then it's very easy to define motion as two or more locations, exist as object that has location, and concept as a relationship between two objects. Okay, what does the word concept mean? It's a word that invokes or involves two objects. All concepts involve two objects, two shapes. Okay, and final issue here, fellow says, matter cannot be eternal. If so, then the universe would be cyclical. Okay, so what if it's cyclical? I mean, the fellow doesn't say any more than that. If he would have elaborated a little bit, we would know what's inside his brain, but he says it would be cyclical. And so what? I mean, is that a crime or what? Is it against the law? I mean, he doesn't explain. Shows you these people. I mean, why does he put a comment if he's not going to expand upon it? You would think that if he says it would be cyclical, and this is the problem with it being cyclical, you would think he explains that, but he doesn't do that. He just says it would be cyclical. Like, we got to read his brain and find out why that's a problem. So I say, so what? So what if it's cyclical? Okay, and then whatever you meant by cyclical, because it could be the alternating universe, the fact that it has a beginning and end, goes back to beginning and then and end and so on, the oscillating universe, right? Could be anything. Who knows what he's talking about? Is he saying history repeats itself? Is he saying that objects will occupy the same location in the next universe when it begins all over again in the second cycle? Who knows what goes through this tiny brain? Okay, by what mechanism does nothing morph into something? That's what he's got to explain. Okay, so if he's going to say that matter cannot be eternal, he's saying it had a beginning. And if it had a beginning, he's got to explain the mechanism before he says something dumb like he said there. He's got to say, this is the mechanism by which matter came into existence. Okay? Otherwise, matter is eternal. Okay, so it's either eternal, it's been there forever, always has been, always will be, or it was space became matter at some point. Nothing became something. And that's when he's denying that it's eternal, he's saying that space became matter. Vacuum turned into an atom. That's what he's saying. Okay, tell me the mechanism. That's what we want to understand. What is the mechanism that you propose? How did space acquire length, width, and height become something? Okay, which is the answer no one can give you from mathematical physics. And again, you can include God if you want in there. I mean, let's assume God is already there. God already exists. We'll concede. Okay, here's the magic wand. We concede God is already there. Okay, how does God turn space, nothing, into something? explain the mechanism. If you can't explain the mechanism, your theory is bunk, nonsense. And I gave you God. What are you going to say? He did it by black magic? You said abracadabra and nothing turned into something? Is that what you're going to tell me? Is that the physics you're going to talk about, that you say matter is not eternal? With that, I'll see you on Sunday. Bye.